Hi. So in the previous tutorial we saw how to create a global CSS style and how to create an action. So now we are going to see how to create a custom view component. So first of all, what is a custom view component? So a view component is something that you use in a view. So for example, an action button is a view component, a tab panel is a view component, a record editor is a view component, a record grid is a view component. And so those come out of the box with Innovation Studio, but as you can see here, I created many components inside this bundle that I'm describing inside another series of video. So for example, this one you would have a custom grid. So if I save it and I preview it, you can see here that I have a grid displaying some data and applying some templates. So you can see here that you have a color in this column. You have a button. When you click on the button, something happens. When you select a row, you have a button as well. So this is a custom view component. This doesn't come with out of the box BMC. And now I'm going to show you how you can create your own. So we have a sample application bundle here, and let's clean everything up. So like I said in the previous tutorial, don't forget to set your SDK home to the SDK folder. So you can see that we're using rx SDK home. It should point to the SDK folder. This is in the documentation, it's very important. So here, just in case I'm setting it again, and because I have two terminal tabs, I will do it twice, but it was already done. But anyway, it doesn't hurt. So how can I create a view component? So like I said, for actions, if you look at the tutorials from the AngularJS SDK, you would have to create the file structure manually. And like I said, for action as well, we give you access to schematics. So schematics is like Maven archetype, so it's a templating system, let's say. So if you are used to Angular development, you will know, for example, the command ng generate component to create a new component or a service. So the idea is exactly the same. So using this ngj command, you can create view component. So the same way we created action, we can do the same thing to create a view component. So let's do that. So you need to be in the web app folder, which is this folder inside bundle. You cannot do that on the root level. You have to be inside the web app. So, and here you are going to type, if you have Angular CLI, you can type directly ngj, but here I'm going to use yarn run because we don't ask you to install Angular CLI. So yarn run ng generate. So we are going to use our own archetype, which is schematic, which is rg view field, no, not field, not yet. Oops, and rx view component, and your view component name. So here I'm going to call it sample view component. Don't feel very inspired. So it's going to create the list of files that are necessary. So here you can see that they created some files and it updated one. So like for action, if you don't want to create actually the file, if you want to see what it's going to do, you can use the dry run parameter. So here I'm going to say I want to create sample component 2. And in this case, what's going to happen is they are going to emulate what's going to happen, but it's without creating the files or modifying the files, actually. So now that we created the sample view component, let's see what happened. So we created a bunch of files inside view component folder. So if I go here, I can see that inside these view components, I have this sample component with a design folder, a runtime folder. And here you can see that it's in blue, so that means that's been modified. So that's why I like to do like to have Git at the same time so I can see exactly what happened. So in green are the new files that have been created, and in blue what has been modified. So if we look at what has been modified, which is on the right, you can see that it automatically imported the new view component module inside the main library, the main Angular library. So like it did, exactly like it did with the custom action. So like we did with the custom action, we are going to directly build and deploy. And once it's done, I will stop the video for now. I will pause it, and once the build and deploy is done, I will resume the video. Okay, so the bundle has been built successfully and deployed. So let's see what's happened inside our bundle at runtime. So we are going to create a new view. So we are going to call it testing sample component. And inside of it, we have our sample application and we have our sample component. So we are going to put it here. There is an error, the message cannot be blank. So here the view component name. So it's a parameter to identify it, so we'll see that a bit later. So for now I'm not going to enter anything here. I'm going to enter a message. I can put a CSS class and it can be hidden. So I'm just going to save for now, and I'm going to launch to preview my view. So you can see here that we have a message containing what I've put inside the message parameter. So let's put a record editor pointing to test. I'm going to put a description field, and here instead of hard coding, here is a message. I'm going to point to this field. So let's see what's going to happen. So refreshing. So here I don't see anything. But when I'm typing something, you can see that the message is reflected at runtime. So this is a sample component, so coming out of the box when you execute the schematic. So let's see a bit its structure and how everything is working. So as we saw in this view component, there are two parts. There is a design and runtime. So what are they? So design is for the design time, which means that whatever is inside the design will be executed at design time, and runtime will be executed at runtime. Because here it's quite simple. For example, we display just in this component that we drop in the canvas like an icon, but it can be much more complex than that. For example, there are some other view components like star rating, where if you change, for example, the label color, so you can see that when I change the value, it reflects in the design time, and when I change the color, automatically the color in the label changes. So you can have a complex design time experience as well. So here that's not what we are interested with. So let's go back to our example. So we have a runtime and we have a design time. So let's begin first by the registration. So this module is a bit special. It's a bit like the module from the action that we saw earlier. It's going to describe the view component. So pretty much like the action, we register the description of your view component inside, this time the RX view component registry service, and we give some information. So first of all, we give the type, and the type is very important. That's the unique name of this view component in the system. So it's very important that this name is unique and does not collide with other view component. So that's why you should have a look at the best practices for naming view component. Usually it's the bundle, the full bundle name, so com example sample app, with the name of the component. The name in itself is more label, so it can be, for example, the sample component. The group is where this view component will appear inside the palette. So here you can see it's sample application. So here I'm going to put a space because it's nicer. Then we have the bundle ID, which is the bundle ID from this view component, so you don't have to change anything here. Then you have the component factory. The component factory is going to describe or declare the runtime component. So we will see that later. And the design component factory is going to register the design time component. So those two, you shouldn't have to touch it because it's basically declaring both component here and here. The design component model, you shouldn't have to touch it as well. It's the design model which is here. And this one will be in charge of a lot of things, setting in design time. So setting the default values for the input parameters, validation of the input parameters, declaring the output parameters, setting the set properties if there are any, and that's pretty much all. So after that, in the property list, and that's the list of our input parameters. So like as the actions, we are only going to declare here the input parameters and not the output parameters. So as for the action, what the input parameters that are declared here are actually declared again inside the design model. So you could ask yourself, why would it be interesting to have the input parameters described twice? So it's because it's better to do it this way. So as for the action, remember that some information are very important. So for example, if you expect your end user or your business analyst rather to have like an expression builder like this one rather than a text field, don't forget to put enable expression evaluation to true. Because as we saw for the action, if you don't pass it to true, what's going to happen here is here, instead of having the value of description like we have here, we would have here the reference of this description field. So it would be dollar something. It would be this. It would be this reference. So rather than evaluating this expression, we would have this expression itself. So that's why enable expression evaluation is very important, and you need to be very careful about that. Localizable is a bit special. So here you can see that localizable is set to true. That means that, for example, here if I set a message like hello world, when I would export the localization strings for this application, I would be able to localize this string. So here it would be used for English, but I could say that this string in French would be bonjour, or something else in German, for example. And in this case, when your web browser, for example, is in French, you would see, instead of saying hello world, you would see the localized version. So this parameter is also interesting if you, in case you want to localize this value. By default, it's not localizable. So here is our registration module. So as we saw here, this registration module is actually imported inside the main library module. So that's how you declare. So you don't, in this main library module, you don't import the design and the runtime modules. This is done already here. And so you just import this one. But once again, if you're using the schematics, this will be done for you. So that's why it's very important that you use the schematics, because it will really fast forward your developer experience. So let's begin by the design time. So first of all, let's go from what is interface. So the interface is listing, as for example, for now, only one interface. And here you can see that it's actually the input parameters. So it's just a way to strongly type the input parameters, and we will use that several times in the different files. So the first one will be the design model. So as for the action, the design model is responsible for some different things. So the first one is to set the default and the current values at design time, validate the input parameters, declare the output parameters, and declare the input parameters that you can set using a button set property action. So here, let's try to go and see through the code. So we are not going to look at the constructor just yet. We are going to look at some other part of the code. So as for the custom action, we have the get initial properties. And this get initial properties is going to set the default values, hidden and message here. And thanks to the spread operator, it's going to override with the current value if there are any. So this method is called automatically. So if you add, for example, a new input parameter, let's say that we do that later, and we'll see what we have to do. Then here we have get settable properties that are dictionary branch. So this one are the properties that you can set using a button set property. So for example, if I have a button here, and in the action I have a set property, you see that in the list of the components I have, this is record editor, but in sample component I have hidden and message, which match those two ones. So automatically you cannot access all the input parameters. You have to declare the input parameters that you can set using a set property action. So here, for example, I could say I want to set the message, and the value will be hello world. So if I save and I refresh, here you can see that when I click on the button, the value has changed. So that's what it does. So we'll see. So this method is not called automatically. We will have to declare this method. So I will show that later. But just remember that here is a list of the properties that can be set. So you have a label that will be displayed in the data dictionary. So here you can see hidden and message. And then the expression, which is the input parameter name itself. So here, for example, it was, if we go to registration module, you would have hidden and message. So if you want to add a new one, same thing, you would have to duplicate some code, so we'll see that later. So here, it's a prepared data dictionary, so it's working pretty much like we did with a custom action. It will return the list of the output parameters for this view component. And for this one, we don't have any. So this one is preparing the inspector configuration, and this is just declaring the input parameters for the view component. So as for the action, you can see that we have a list of input parameters. So here under general, here we have general. So we could have multiple tabs. So here we have only general, but we could have multiple tabs. Like here we have general, actions, and security. So we have multiple sections. We could have multiple sections as well. So here it's a list of sections here. So inspector section configs. So here we have only one section, which is general. And the controls are going to list all the input parameters. So name is a component, text form control component, so which is a regular free text. So as I explained, for the action, you can have multiple types. So here we have text, you have expression for the expression builder, you have tags, which is a special case I will explain a bit later for CSS classes. And here for hidden, we have a switch, an optional expression control component. So the main difference is in options. In options, the options need to match pretty much the type of component. So here, for example, for an expression, we have an interface for it, and it will tell you everything that you can do with this component. So for example, here, using the IntelliSense, you can see that we have pretty much only is label hidden and expression editor property name. We implemented everything else. But here, if I hide is required, we would see is required. So that's pretty cool. That's a big difference with AngularJS. So here you can see that for a text form control component, it's pretty simple. You just have to give the label. It will be displayed here. And here we have a tooltip, and that will automatically give the user some guidance what to enter. Then we have a message, which is type expression from control component, so which is an expression builder. So the options interface is iExpression from control options, which has some properties. So label. So once again, what's going to be displayed here is required is going to match this required indicator. Tooltip. And those two information, like I said, for actions are mandatory, but you can just copy them from another view component, for example, if you have to. You can customize the data dictionary and the operators, but 99% of the time you don't need to do that. It says what should appear in the data dictionary here and the operators that are here. So but the default one are usually the good ones. So for styles, we have a special component which is tag. So here a tag is displayed like that. Oops. And because it's a CSS class, we have a specific error check validate CSS class name. So this is coming from out of the box. That is a CSS class validator. So it's not going to check if your CSS class exists, but it's going to check that the name is valid. That's all it's going to do. So same thing, it has a label, it has a placeholder. So you can see here add CSS classes, which is here. So different options, different interface have different values, possible values. And here we have a type optional expression control component, which is a bit special. Because here if I put hidden, you can see that it's not simply a switch. It's something where you can have at all times when condition is true, and here you can put a condition. So for example, here I could say it's hidden when description equal foobar. So here I can see, and you can see that when it matches foobar, automatically disappears. So this one is actually quite complex, so it's a nice thing that we provide it out of the box. Of course, you will have to handle it during the runtime. So what do we have next? We have validate. So in the validate, it's pretty much as well like in the action. So we pass inside the model the different input parameters that we can check. We can add validation issues, and we pass them back. So for example, here you can see that the message cannot be blank. That's a message we saw earlier. So here if I put this, you can see that I have my message cannot be blank, and if I click on it, it will go to the view component, the right view component. So you can use a sandbox creator for that. So most of the methods we saw, validate, set inspector config, prepare data dictionary, and so on, are not called directly by the parent, which is view designer component model and iView designer component model. So we need to declare them inside the constructor. So the first one that we do usually is updating the inspector config. And the inspector config is what we have here on the second tab. So it's a view component inspector list, what we describe as the input parameters. So we are calling the sandbox update inspector config and passing our inspector object. So that's the inspector. Then we have the validation, and the validation is a bit, it's a bit complex. The only thing you need to know is basically, because we give that code to you as part of the schematics, that your custom validation is going to be this one. So what it does, it taking each time the component properties, which are the input parameters, are going to be modified, it's going to call your validation. So each time you type something, the validation is going to kick in. And when it's done, it's going to add the validation issues to the existing validation issues from other view component, for example. So this is quite important. Then we have this piece of code that is a bit special. So here what it does is, you can see that it's looking at name. And name is actually an input parameter here that you can see here. And you could say that, well, it's weird, it's not here. Name is a special input parameter, and what is used for is, here if I put something like Calvin, and if I put another sample component I'm going to call hops, you could say that if I have multiple view components of the same type and I can use it like a set property, there would be a problem if like we had exactly the same name, right? Just sample component. So here you can see that I know exactly what's going on because I pretty much gave a label to this view component. So I know that here I'm going to set the one that I named Calvin and this one that I called Hobbs. If I didn't do that, so if I had something like this, well, which one is one? Which one is the right one, right? So message is, name is a bit of a special attribute that allows you to name your view component. So it's used mainly in the grid and record editors, but it's kind of cool to have it, especially if you have like components like graphs, where you could have multiple inside your page. It's a nice way to have. So here we are going to name it Calvin. Here, this one, we are going to call it Hobbs. We are going to give it a value, so we don't have errors. And we are going to save the view. So name is a bit of a special case, but what is interesting here is we are subscribing to the change of this input parameter. So when the input parameter name changes, we are subscribing to it. And what we are going to do is we are going to call two different things. One is the settable properties, data dictionary. So the list of input parameters the user can use in set property. So exactly what we saw here. So that's why we see here Calvin and Hobbs, because we are rebuilding the data dictionary. And it does the same thing for the output parameters, because the output parameters will also be accessible. For example, here, if there was a output parameter, here I would have the component returning the output parameter. So I would need to update as well the output parameter data dictionary. So we'll see later how to create a new output parameter. So this is pretty much for the model. So this one is pretty much a full logic for the design time. So most of the time you don't really need to change anything here. Maybe you need to add like a couple of view component, maybe a couple of input parameters, for example, but that's pretty much all. So now let's see what do we have. So we have a module. The module is a simple Angular module, and this module is going to be imported in the registration module. And so we have a component because we display something inside the canvas, right? We display this. And this is just an Angular component. So as you can see, it's that simple. It's just a regular Angular component, and it has a model passed by the sample component design model, but we don't do anything with it. And in the HTML, it's even more simple. It's just the wall icon, right? It's incredibly simple. So most of the time, you don't have to do anything special for the view component design time. It's mostly what I do usually. It's just an icon that is centered and a little big. That's pretty much all. It's pretty rare that I do like a really complex design time experience. Some of them are a bit complex, like the wizard, for example. It is way more complex, but most of the time it's not worth it. But if you want to have like a complex design time experience, that's where you can do it. Like it would be inside the design time component, HTML and TS. So let's see how we can create a new input parameter and implement it. So here I'm going to go there. I'm going to duplicate this and I'm going to call it message type. I don't want it localizable because I don't care, and I want it to be, yeah, that's fine. So first of all, we need to go inside our interface and we want to declare it. So it's going to be a string. So we are going to add it here. Then we go in our design model, and as you can see, it already complains about some things missing. That it's missing message type, because here this initial component properties is implementing this interface. I'm going to go here, IntelliSense is saving my day, I'm using message type. So I'm scrolling down, so here it's getting the default and the current value, so I need it here as well. So the default value is going to be empty string. I don't really want it to set it. If I wanted to set it, I just would need to do something like this. And it would be settable using set property, but I don't really want to do that in this example. So here I just want to add another type. So I'm going to do something like that. I'm going to duplicate the code. I'm going to remove that. So the name is just the input parameter name. So it's not the label. You need to be very careful. There it's going to be the message type. I don't really want a tooltip. It's not going to be required. And I still need the data dictionary and operators. So if you want to have like a different expression, a different form control component, different inspector, you have an example inside test 2505 bundle where I list pretty much all the different inspector types. So you can use IntelliSense and you can type form control component, and you can see basically pretty much everything. So if I wanted, it could be a color picker. It could be pretty much, anything. So here in this case, I still want an expression from control component. And I think we are good for this new input parameter. So now what we want is maybe add a validation for it. So it's going to be message type. And we are going to check if foobar. And here we are going to say that foobar is forbidden. And of course, the property name needs to match the input parameter name. So here we are good. And what we want now is to add maybe an output parameter to see how it works. So in order to prepare our data dictionary, we have to declare basically the output parameters like we did with custom action. So the format is, as you can see here, this interface, so we can look at it and we can see that what it expects. So a label, an expression, children, autocomplete options. The label is mandatory, and we'll need to use, of course, the expression to tell what it's going to be. So we need to declare what is going to be our view parameter. So our output parameter. So we need to return not null. So we need to return an object. It's complaining. So the label is going to be API. Oops, sorry, component name. Then we need to pass the expression, and the expression is get expression property of API. So let me type it first, and I will explain what this magic does. So we are going to implement the children, and the children are actually the output parameters. So here we have a label, and the label is going to be simple output. Then we have an expression, get expression property, and we are going to call this variable simple output. Let's clean it up. So what does it do? So here you can see that we pass an object, and this object contains in children the list of the output parameters. So here, if I had multiple output parameter, I could do something like this. So here I would have 2 output parameters. But here, the thing that is interesting is in the label we have the component name that is automatically passed, as you remember, by the component name with the name. So if we look at here, we will have something like this: sample component Calvin, sample component Hobbes. So that what will contain the component name. Inside the expression, we are going actually to modify the internal API of this view component to pass the list of the output parameters. So basically, every time those lines will stay the same. The structure will stay the same, so you can copy it from another view component if you want to. So the only thing that is going to be different is the list of the output parameter, which are here. So here you have the label of the output parameter, and here you have the output parameter variable name that will be used later at runtime. But now we don't have to worry too much about it. So now we have pretty much everything ready. So let's build this bundle, deploy it, and see how it goes. So as always, I'm going to let it build, deploy, and I will resume later. So the bundle has been built and deployed. So we are going to refresh the view and see what's the difference. So here in my set property, I still have my 2 properties in the message, nothing has changed. Here you can see that I have a new input parameter, message type, and I can set it to whatever I want. There's no error. And this one, if I put foobar, so as we can see here, it's not working. I have foobar and I don't have an error, which is a problem. I mean, clearly here I'm testing foobar, but we are used to it. I mean, we saw it during the action. I am a bad developer. So that's a perfect opportunity to see how we can debug that. So how can we debug our code? So as we saw during the action, we can just use ngserve, or pretty much like any Angular application. So we have a command line for that, which is npm start API host and the domain name from Innovation Studio Server. So you don't need to give the port 8008. It's going to deduce it automatically. So npm start -- API host equal, and for me it's the API of my Innovation Studio Server inside the web app folder, the same folder you use to create the schematic. So I'm going to tap enter. And so it's going to build. It's going to take a bit of time, so I will pause and we'll see each other after everything is ready. So it's ready. So ngserve has been launched with some parameters, and you can see that the debug is available at localhost 4200, and it actually launched a page which is not really useful right now. So how can we debug this page? Well, it's very easy. We just have to take the URL and paste it after the localhost 4200. Type enter, and here we go. So here we have our view component that doesn't work. So let's see how we can debug that. So I'm going to type F12, and okay, here I cheated because everything is ready. It's scripted, but don't say anything. So I want to debug one specific file, and this file is sample component-design.model.ts. So I'm going to go Chrome, sample component design model.ts, and you can see that I have my source file here. Exactly the same. So I go to validate, and I'm going to put a breakpoint here because I want to know what's going on. So let's see if I can make it a bit nicer so we can see everything at once. Don't really need this one. So here let's change the value. So here I have foobar. What happens when I put foobar 2? Okay, so it stops here, and let's see the value. The value is, oh, there is a double quote because it's a string, it's not a variable. So that's a problem. That's my issue. So let's go here. We could do something a bit better, but I mean, that's not the goal here. So I'm just going to say if it's equal at foobar string. I'm going to save it automatically, and ngserve is going to kick in, and it will rebuild the necessary chunks. So here it's done. Let's go back to my debug page. Let's free the breakpoint. It will reload automatically the page. And now you can see that it complains foobar is forbidden, and I can change the value. So my bug is now fixed, but of course in the production version, I mean the bug is still here, so I will need to deploy the bundle to have the fix. But here is how we debug live a view component, and you can see how we did it for the design time, and we'll see it as well for runtime because there is no doubt I will mess something up at runtime as well. So for now we're going to close this one, we are going to stop the debugger, and we are pretty much done for the design experience. So now let's go back to runtime. So runtime, as you guessed, is pretty much anything that happened at runtime. So the runtime version of our view component. So what's the structure? So the structure looks pretty much like the one in design time, but a bit more simple. So you can see that there is no design model because there is no need for validating the input parameters. The only thing we have is the component. HTML, component TS, and its CSS. Here we have a module, which is a very simple Angular module that imports our component and export it. And this component module is imported inside the sample registration module, like we did with the design time. It's imported here. And our component here, so the sample component, is declared inside the component factory resolver. So very simple, regular Angular module. So let's see what happens in our component, which is the interesting part. So here we can see in the HTML that it's just a p tag, PHTML tag, containing a list of class with a hidden parameter and displaying a message. So it matches pretty much what we have here. And the interesting part is a class list. What does it do? So here, if you follow the tutorial on the global CSS style, you can see here that you have a CSS classes input. So let's go to the styles folder, open this one, and let's see what happens when you select this style that we created earlier. So we're going to put inside CSS class. We are going to save, refresh, and you can see here that we have a blue border. So it doesn't have any background color because there is already one, but at least we can see that the border has been changed. So that's what the class list is doing. After that, you can look at, this is standard Angular attributes, so you can look at how it works. So basically here we are just setting class list and the hidden attribute. So when the input parameters is set to hidden, and here we just display the message. The message that is set here, world. So in our case, what we could do actually, if really we have all the input parameters and input params, things that I don't really know, and we'll find out later. Let's see what happens when I do something very ugly like that. Okay, I have a message type here. So here, of course, I cannot see the difference immediately because I am in runtime. I'm in production mode here, right? So it's not going to do anything. So I would need, for example, to enable debugging. So that's one thing that is really cool with the debugging mode. It's used for debugging, but also for coding. Because this way you don't have to deploy your bundle every time. You just have to run pretty much everything in debug mode, and you can see anything you change pretty much immediately. So let's do just that. So the debug mode has been launched again. So let's go here. It launched the default page. We are going to take the URL. Just paste it here. So you might have to log in again because it's a different session. And here you can see what is the immediate difference, right? You can see world and whatever I want. So that means that everything I've done is working. So let's see, let's say that I want to do something a bit different. I want to put the message type actually before. Oops. I want to do something like that. So here it's going to take the changes automatically and build the code, and the page reloads automatically, and whatever I want, world. So we can do the same thing with the classes. Here you can see you have a background color. I'm not sure I want that actually. I'm just going to comment it out. Going to save. So it's going to compile. And now I have my CSS class that has been applied here, which was completely blue. So now you can see that you can actually code pretty much live. I mean, you could do that already with the previous SDK using Grunt. So you have the same developer experience, but for runtime and design time. So here we are good. Let's see how it works on the component logic side. So we have on our TS side. So what do we have? So it's pretty simple. So here is what we have. So we have our sample component that extends the base view component with some information that are set by the parent. So for example, the GUID. And what we want to do is something a bit special. So remember that we define some input parameters that could be set using set property. So here, for example, when I click on this button, the message would be changed into hello world, right? So that's where we will tell what happens when we have a set property that is called. So we define an API object, and we say that for set property, we are going to use our own version of set property, which is defined here. And what you see here is what's happening. So in property path, we have the input parameter name. So we are expecting hidden and message. If for some occasion we have something different, so let's say that at some occasion we had like another message type, for example, let's say we had message type and we removed it in the code, the best practice is to catch it and to throw an error saying that we try to set message type and we cannot actually set it. That's the right way to do it. So you can throw an error or you can use our logger. So I think it's Rx log service. So you could do something that would be a bit cleaner. Do we have a constructor? We don't. So we need to import it. So I'm going to create a constructor, private. So you can see that automatically it imported the Rx log service. I'm going to call minus Rx log service. And here, instead of returning, throwing an error, I would do something like this.rx.service. Warning and this message. Something like this. The same way we could show a notification. So if I want to do a notification, I don't remember exactly what is a BMC out of the box service, I can do Rx, so I guess it's notification, and it's a service, so it must be this one. So same thing, I'm going to go here, I'm going to leverage it. So automatically it has been imported. And I'm going to leverage it. So I'm going to do this dot add warning message. Is not settable. But you know what? Let's take that. And here we set the message. So we are going to just display the message. So it's going to be the property value, and it's information message. So I'm going to save. I should reflect, and let's see what happens when I click on no button. You can see now that I display a notification message. I set it to hello world. So that's how it's working. We trap, we implement and override set property for view component. So here we are there. The constructor, there was nothing in it. We just leverage it to import some BMC out of the box services. And the most important part and interesting part inside the ng on init. And in this one, you can see that it's taking the config object, which is an observable, which contains actually the input parameters, and we are going to subscribe to it. And we are going to store those input parameters inside this input parameters variable that we used here. So that's what it does. We subscribe to the input parameters and we just update input params. So this is a way to do it. There is actually a slightly better way to do that, and I'm going to give it to you. It's pretty much in all the example I made, but I mean, let's do it the right way. So here you can see that we just subscribe. So every time something is modified, we are going to update the configuration. So the right way to do it is actually to do a pipe. So RxJS. And we have basically two conditions that we want to do. Only fire when the configuration is different, and only until the parent view component is not destroyed. So destroyed is usually when your view component, for example, you refresh the page, the view component is destroyed. So we would use take until, and then we would use something like destroyed. And here you would be until changed. So we compare the value of config, and you would need, because it's an object, and this take until change is not really good with object, we would have to use like is equal. So is equal is like a utility from Lodash. Is equal from Lodash. So I mean, this doesn't make a lot of difference in this use case, but it can make a big difference in some other view components. So, but that's the right way to do it. So you would receive only the subscription when the configuration object actually change, its value actually change, and the subscription will stop automatically when the view component is destroyed. So here everything works as normal. Nothing has changed. So this is a way that comes with schematics, and this is a way that's actually a bit better. So we saw earlier that we implemented the set property on API, and we need to propagate this value. We need to tell to the system we overrode set property. And for that we are going to use notify property changed, that is inherited from the parent. And we are going to say that API, we are going to change that by our version of API object. So in our case, we only overrode set property. You can actually override more function like refresh. And refresh is used, for example, when here you have a refresh action. So here I could say I want to refresh this view component. So here it wouldn't do anything because I didn't implement this refresh, but if I wanted to, I could do something like that. I could do refresh, and here I would have to implement a refresh method. So I could do something like this. Let's see, I would do refresh, and here I would do rx notification service dot message I am being refreshed. So let's see if that works. When the page reloads, we need to add here, for example, refresh on good question, which one? Calvin. So up, refresh, saving the view, refreshing the page, and I am being refreshed. And here I've got an error, so we'll debug that a bit later. Because I guess I didn't, I'm not returning exactly what is expected here for the refresh method. So that's a good opportunity to debug it a bit later. But anyway, it's working. The implementation of refresh is working. So that's pretty much all for the view component. So we have now, we created an output parameter. So we want to do something with that. So let's first do the output parameter. So how does it work? It's very simple. The way it works is the same way we have this notify property changed for API. We can actually do the same thing for any value. And here the property name would simply be the output parameter name, which is simple input output. So here you would say simple input any value. So here I'm going to save. And at runtime, he would send this value, any value inside the simple output. Now, of course, the problem that we have right now is, for example, here you can see that my sample view component has a simple output. So we need to set to receive this value somewhere. So I'm going to take this assignee field. I'm going to map it to simple output, which is output parameter. I'm going to refresh, and you can see here that my output parameter is correctly set to any value. So amazingly, this worked from the first time. So the only thing that is not working is this weird error. So cannot read property pipe of undefined. So let's see first of all where the problem is. So same thing, so I guess the problem is not in the design model, so I'm going to remove the breakpoint. I need to look for sample app.component.ts, and I guess the problem is here. So let's try to make it user friendly. I'm going to refresh. So far perfect, no error. And here is the problem. So let's take here. Let's see if we have some information. So it's basically in BMC code. That's something it doesn't like something in the view runtime.js. So you can see there is a subscription going on next. Okay, so clearly there is something going on with observables. So here it's executing something, and when it's executing something, there is a pipe. So if there is a pipe, that means that, I mean, it should be an observable. And if we look at the code that I did, well, it returns nothing, it's void, right? So first of all, this function should return an observable, I guess any, even if it's very ugly. And let's try to return an empty observable. So, which is from RxJS. So let's save. Okay, so the page should refresh. And now I don't have any error anymore. It's magic. So what do we see? What did we see in this very long tutorial? Once again, I'm sorry about that. So we saw how to create a custom view component. We saw how to declare input parameters, output parameters, validation, setting properties. We saw how to do that in design time, and we saw how to subscribe to the input parameters at runtime, and add some new input parameters, how to broadcast an output parameter using notify property changed, how to override set property, how to override